In solving this radical equation, I see that my square root is already isolated on the left side, so I'm ready to undo the radical. It's a square root, so I am going to square both sides. That gives me just this x minus 6 on the left side. On the right side, I do have a binomial squared, so I would want to think of this like an x minus 8 times another x minus 8, and then FOIL this out and combine like terms. If you did that, you would end up with an x squared. Your o and your I parts of FOIL would be a minus 8x and another minus 8x, which would give us a minus 16x, and then a plus 64 on the end. So if you FOIL and combine your like terms, this is the trinomial that you would end up with when you square out that x minus 8. When I take a look at this equation that we have in this next step, I see we have both x squared terms and x terms. So I likely will need to either factor or maybe use the quadratic formula in order to go through and solve. Either way, I would like to have this left side equal to 0. Let me subtract an x on both sides. And after I do that step, in the next step, what I would like to do is add 6 on both sides. If you are doing addition and subtraction steps, 2 steps in a row, you can do them in one big step if you'd like. I can subtract x plus 6 on both sides here. That's still a legitimate step, and that saves us 1 step of work. Now we have gotten 0 over on the left side of the equal sign in just 1 step. So to solve this, I do want 0 on one side of our equal sign. Then from there, you can go through, and since this is a quadratic, either try to factor or use the quadratic formula. I'm going to try to factor. There's nothing in common with those 3 terms. Looking for 2 numbers that add to be a negative 17 and multiply to be 1 times 70, which is 70. Those 2 numbers would be negative 7 and negative 10, and I can use the shortcut to factor because of the 1 in front of the x squared. Then using our zero product property, I can break this up into 2 equations and solve. Going back and taking a look at the beginning of the problem here, when we did raise both sides to a power we were squaring, that is an even number. So I'm not sure if these are actual solutions or if they are extraneous solutions, so I do need to plug those back into the original. First, let me check and see if x really is equal to 7. Let me plug that in. That would give me the square root of 7 minus 6 is equal to 7 minus 8. And if I evaluate that, 7 minus 6 is 1, and the square root of 1 is 1. 7 minus 8 is a negative 1. 1 is not equal to a negative 1, so no. X is not equal to 7 in this problem, and we need to eliminate that from our solutions list. It was an extraneous solution that got introduced into this problem when we squared both sides. Let's see if x is 10. We'll plug that in also. So that would be the square root of 10 minus 6. I want to see if that's equal to 10 minus 8. 10 minus 6 is 4, and the square root of 4 is 2. 10 minus 8 is also 2, so that does verify that 10 is a solution. So there's just one solution to this problem. We ended up with an extraneous solution when we went through and did the solving process. It's a good demonstration as to why when you raise both sides to an even power at some point in the problem in your solving process, why you need to plug your solutions back in to see if they are actual solutions or not.